let us see working of rectifier using capacitor filter. Now, as we have seen in last lecture, bridge rectifier is also a full wave rectifier which converts single phase AC supply into pulsating DC. Here we can see construction of bridge rectifier. In positive half cycle, what happens? This point of secondary, this is our step down transformer, and this side is called as secondary side. Now this point of secondary becomes positive with respect to this side. That's why diode D2 and D3 becomes forward bias and comes into conduction. And at this point we are getting one pulse, this type of pulse. Similarly, in negative half cycle, this point of secondary becomes positive and this point becomes negative. That's why diode D4 and D1 becomes forward bias, and again we are getting this type of pulse. Now this type of waveform or this type of output wave is called as pulsating DC. Pulsating DC. But for our DC applications, this type of signal is not required. We required ideal, that is DC, that is horizontal line, approximately horizontal. That's why we are using here capacitor filter. Now we must keep into mind that capacitor is always connected in parallel with load. Here we can see this capacitor connected in parallel with load. If you use inductor filter, inductor connects in series with load. Now let us see how this capacitor filter work. Here we can see in this positive half cycle, diode D2 and D3 becomes forward bias, and here we are getting this type of pulse. Now from this point A, capacitor starts charging. Capacitor C starts charging, that is it starts to store charge until point B. At point B, capacitor charges fully, and again when this voltage tries to decrease, the charge on capacitor does not goes to 0 like this voltage. This charge is held by load resistor, and capacitor discharges through this load resistor with rate of that time is called as RC time constant, given by tau is equal to R into C. That is, this discharge rate is decided by value of resistor and value of capacitor. If value of resistor and capacitor is more, then the discharge time is also more. Again at point C, when capacitor discharges to some particular value, and if again in next half cycle this output pulse appears at the input of capacitor, here at the input of capacitor again second pulse appears, capacitor again starts charging from point C to point D. Again when this pulsating DC voltage becomes 0, again capacitor starts discharging, but it does not discharge with this voltage, it holds its charge given by RC time constant. And this way we are getting here this type of DC waveform. This type of DC waveform again can be made to approximate DC by using voltage regulator. This is working of capacitor filter.